Let's begin this lesson by reviewing something that was in the last video. And I would say that if you have not done the previous module and worked through its video, then this isn't going to make much sense. So make sure this is done in order. I'm going to review what we call the cast rule. The cast rule is used to obtain the positive and negative values for sine, cosine, and tangent in the four quadrants of those reference angles. So in the first quadrant, the reference angle sits here, and we would calculate sine, cosine, and tangent by comparing the sides that they relate to. So the opposite is our y value, and our hypotenuse is here. So opposite to hypotenuse makes this a positive value. When we compare the adjacent to the hypotenuse, that is also a positive value. And you could see tangent would also be positive. In this case, we learned that all of them are positive. And you can see why. In this quadrant, everybody is positive, and so it makes total sense. Let's go to the next quadrant. In the next quadrant, quadrant 2, we notice that sine, the y value to the hypotenuse, is still a positive. So it is a positive value. Cosine is our next value, and this is our first time we see a negative appear. So this x value is negative to the hypotenuse, and so the overall values will be negative. Tangent will also have that same issue because opposite to adjacent will be a negative answer. You could test these out, like if you typed in the cosine of 100 degrees, you'd get a negative answer. So let's summarize this value over here as well. Sine is the only positive that is taking place there. When we move into quadrant 3, we find out that sine would be this y value over this hypotenuse, and so that would be negative. You can see that cosine would be negative as well. And the positive one becomes tangent because the opposite is negative, the negative y, and the negative x will make that one a positive. So in this category, we get tangent being the only positive values. In the final quadrant, we see sine being a negative because this is negative divided by positive. And then we see cosine being positive. Yay for cosine. We see that happen because the adjacent, this is a positive x, divided by the hypotenuse, that is always positive. And then finally, tangent is negative. This is where we get our cast rule. C, A, S, T. And so you can easily refer to an angle, whether it's positive or negative, by that rule. So if we said the sine of, let's try 142, and they ask you, is this positive or negative? That's an easy thing. Cast rule says 142 is in here. This will be positive. If they said, what's the tangent of 300? 300 is in this quadrant, and so it would be a negative. So it's easy to use the cast rule to determine positive and negative values very quickly. What if they said the sine is, 0.03 and cosine is negative 0.4, and they wanted to know what quadrant you're in? Well, that's an interesting question. So which one am I in if those are the values that I have? So sine is positive, so we know that it has to be either in here or here. And cosine is negative in, let's see, so cast would tell us cosine is negative in this quadrant. So it's this quadrant would be our answer, number 2, because in that quadrant sine would be positive and cosine would be negative. That would be the only location that that would take place. Another style of question in this area is to give you a point. Let's give you the point negative 8 and 15. Negative 8 and 15 would land you somewhere over here. And what this question is asking you to do is lots of different things depending on the actual question, but it might ask you what is the referencing angle for that particular point. And so you could use your tangent function, your inverse of your tangent, to say it's the opposite, which is y divided by the x, to obtain your referencing angle. They might ask you for a particular ratio. They might say, what's the sine ratio of that? And you know the opposite is 15, but you are unaware of the hypotenuse. And so what you would do to find that hypotenuse is you would use your Pythagorean theorem, negative 8 squared plus 15 squared equals x squared. You would find that that's 17, and now you're ready to give the answer of the sine ratio being 15/17. So that's a type of problem that you'll see in this area as well. And then finally we have probably the most important part. Not all reference angles are alike. And what I mean by that is in geometry and earlier in this unit we reviewed what we referred to as the special right triangles. Those special right triangles are huge right now. And so they become 3 very important reference angles. So the first one we'll look at is the 45-45. And let's review what we know about it. We know that the two sides will be the same, and we'll just use 1 in this case. And then the hypotenuse is root 2 times bigger, and so it would just be root 2. Now, this particular reference angle, we can obtain the values for sine, cosine, and tangent, and we'll do that now. Sine, cosine, and tangent. Whoops. Let's get that right. Of 45. Now, sine would be 1 over root 2. Cosine would be 1 over root 2. And tangent would be 1. We normally don't leave our denominators as a radical, and if you rationalize this, you would get these values here. This is the more typical way that these are kept. So we'll come back to these, but I wanted you to see where these values come from. These become very, very important values for you to memorize and to learn. Let's look at the next special reference angle. The 30-degree reference angle will be next. Let's use the numbers of 1 for our short leg, times 2 would be divided by 2, and then times root 3 would be root 3. So if we were doing these, the sine of a 30 degree would be 1 over 2. Let's see, cosine would be of 30 would be the adjacent root 3 over 2. And tangent would be 1 over root 3. And ultimately, again, this one gets rationalized, and when you rationalize this, it just becomes root 3 over 3. So these values here will become important to us. These are known as exact values for sine, cosine, and tangent at a reference angle of 30. Let's look at one more, the 60-degree angle. So let's label the short leg a 1. That makes the hypotenuse a 2 and the long leg a root 3. If we were to do sine of 60 degrees, it would be root 3 over 2. If we were to do cosine of 60 degrees, it would be 1 over 2. And if we were to do tangent of 60 degrees, it would simply be root 3 over 1, or root 3. These values don't need to be simplified at all. They are in their current or easiest form, and again are very key values. Let's summarize this in a table of what we've seen so far. So we found the sine of 30 to be 1/2, the sine of 45 to be root 2 over 2, and the sine of 60 to be root 3 over 2. We found cosine of 30 to be root 3 over 2. We found its 45 to be root 2 over 2, and its cosine of 60 to be 1/2. Tangent at 30 was root 3 over 3. Tangent at 45 was 1, and the tangent at 60 was root 3. These values, I know they are tricky and seem obscure, are very important to us. They get used a lot in mathematics from this point on, and really pays dividends to memorize them. So I'm going to give you a strategy for learning these in a fairly simple way. I'll do that now. Notice in my new chart I've added 0 and 90. This is going to help me to complete even a wider range of values that I should know or memorize. And the way I'm going to do this is kind of, I don't know, it's just an algorithm for creating these values, and it's a nice one, I think. So just watch what I'm going to do. I'm going to write the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2. So did you see my pattern? I just did square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. And what's kind of cool about that is that this simplifies to 0, because the square root of 0 is 0 divided by 2 is 0. Square root of 1 is 1, so this simplifies to 1/2. This stays as it is, root 2 over 2. This stays as it is, root 3 over 2. And the square root of 4 is 2, and 2 divided by 2 is 1. Now once you have the sine values, guess what? The cosine values you get for free, because they are decreasing values but are the exact same values. So do you see how sine was increasing in that quadrant and cosine was decreasing in that, but they are the exact same values. Tangent requires a little bit of memorization. Remember, tangent is slope, so we had a 0 at 0, we had 1 at 45, and we were undefined at 90. The only thing that I feel you actually memorize is these two, which is square root of 3 over 3 and the square root of 3. To me, in the entire chart, the only ones I have to kind of memorize are those two, and everything else fills itself in. This chart becomes huge to refer to, and we'll do a couple of quick questions now. So here's how these questions go, and these are really important ones. What's the exact value of the sine of 300? So you're like, how in the world could I do that? Well, let's start with finding our reference angle. The reference angle for 300 is found right here. So 300 is this big angle, and that means our referencing angle is 60. So what we need is to know what's the value of the sine of 60. So knowing my little chart here, let's pull it up. The sine of 60 is right here. And so if I highlight that, that's its value. Now, that's as easy as it is, except for one thing. You have to remember of the cast rule. So the cast rule would say that the sine in this quadrant is negative. So your answer is negative square root of 3 over 2 would be the answer to this problem, because if I can move it to the reference angle, I know the values of the reference angles. That's what this chart really is it's those exact values of special reference angles. And so it keeps getting referred to. Let's do another one. All right, the tangent of 120. So let's first think about where that is and what's the referencing angle. The tangent of 120 puts us somewhere in here. This would be 120. What is our referencing angle? It's always formed between the x-axis and the terminal arm. So that happens to be a 60 again. And so what I would need to know is what's the tangent of 60. Let's bring up that table. So now we're interested in the tangent of a reference angle of 60. Tangent at 60 is right here. And so our answer is going to be the square root of 3. But we need to go check our cast rule as to whether it will be positive or negative. And in that quadrant, sine is the only positive one. So our exact value would be the square root of negative 3. This is how we obtain exact values for any reference angle of 30, 45, or 60. And again, I cannot emphasize how important they are.